Good morning. I am David, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology, Kanyakumari District. In this video, I am going to teach you a small topics from the first unit of hydraulics and pneumatic subject. In our syllabus, the first unit is fluid power principles and hydraulic pumps. So first we want to know what is meant by fluid power. So fluid power, it may be defined as the technology that deals with the generation, control and transmission of power using pressurized fluids. Then these fluid power transmission systems are divided into two types. First one is hydraulic power transmission system. The next one is pneumatic power transmission system. So it can be defined if in the fluid power system the working medium is a liquid, means that transmission system is called hydraulic power transmission system. If the working medium is a gas or air, means that is pneumatic power transmission system. This is one important thing, that is principle of hydraulic power transmission system. So all the hydraulic power transmission systems are working under the principle of Pascal's law. So already you may know the Pascal's law. The Pascal's law states the intensity of pressure at a point in a static fluid is same at all points. So this can be explained by some experiment, that is, so by means of this experiment we can explain the Pascal's law. So for this experiment we need two cylinders, that is one is a small cylinder, another one is a large cylinder. These two cylinders are connected by means of a tube. Then these two cylinders are filled with a liquid. Then if you give some force in the small cylinder through a piston, a pressure will be created at the bottom of the piston. That pressure will be available in all the particles of the fluid. So when we calculate the force, we get as the output in the large cylinder is more when we compare the F1 force. By means of the small amount of force, we get more amount of force. Okay, this can be calculated by means of Pascal's principle. So we know Pascal's law states the pressure at all points is same, that is P1 is equal to P2. So we can see the calculation side. So let us consider A1 is equal to the area of small cylinder, A2 is equal to area of large cylinder. Same as F1 is force given to the small cylinder, F2 is force output at the large cylinder. So as per Pascal's law, we know P1 is equal to P2. So we know the pressure of the formula of pressure is force by area. So F1 by A1 is equal to F2 by A2. So the output force get at the large cylinder is P1 into A2, otherwise F1 by A1 into A2. So depending upon the area available in the large cylinder, we get the multiplication of force. Then we can see the second chapter available in the first unit, that is hydraulic pumps. So already you may studied about pumps. So pumps are used in hydraulic power transmission systems. So it will be used in hydraulic power transmission system only. Pumps are considered as the heart of the hydraulic system. So it is the main part of the hydraulic system. So already you may know the pump, the working principle of pump is the pump converts the mechanical energy into the pressure energy of fluid or hydraulic energy. Then classification of pumps. The pumps are mainly classified into two types. So all the pumps will become under these two types, that is positive displacement pump and non-positive displacement pump. So simply we can see the definition. A positive displacement pump has an expanding cavity on the suction side and a decreasing cavity on the discharge side. Fluid flows into the pumps as the cavity on the suction side expands and the liquid flows out of the discharge as the cavity collapses. The volume is a constant given each cycle of operation. So mainly in positive displacement pump, in every stroke of the pump or every rotation of the pump, the equal quantity of fluid will be delivery. So that is the main thing of positive displacement pump. The important example of positive displacement pump is many types of pumps are available. So among that, gear pump is one important type of positive displacement pump. Then we can see non-displacement, non-positive displacement pump. So second type, the most common types of dynamic pumps are the centrifugal and axial pumps. The non-positive displacement pumps are also called dynamic pumps. The example of this type of pumps are centrifugal pumps. Although these pumps are provide smooth continuous flow, their flow output is reduced as circuit resistance is increased and thus are rarely used in fluid power systems. So in non-positive displacement pump, the equal quantity of fluid will not delivery for the every revolution of impeller or every stroke of the pump. So this is the main disadvantage of this pump. In hydraulic power systems, mainly positive displacement pumps only we will use. So this is the centrifugal pump. Centrifugal pump is a major example of non-positive displacement pump. So I think you have studied a simple thing about the first unit of hydraulics and pneumatics. Thank you for watching.